Hey class. In this video we'll be talking about interaction again. Earlier this semester we talked about interaction using mouse X, mouse Y, and functions like mousePressed to create simple interactions between the user and our sketch. In this video we're going to use a new concept called collision to determine whether or not the user has clicked inside of an area, such as a circle or a rectangle. This will allow us to create buttons that can refine the type of user input that we have. Instead of just an area of the canvas, we'll be able to detect input for the user in a specific visual space, which we often refer to as a button. This concept is important for a lot of different applications in software development. It can be used for games to determine collisions between characters and objects, and it can be used for any type of user interface to determine if a user is clicking on something or directing an avatar into a specific area. We can use the collisions to trigger events like a change in color or playing a sound. So we'll go over how the collisions work first, and then we will add some visuals and some sounds back into our project like we had in the last video. So let's get started. I'm going to open up GitHub, make sure I'm on MMP 210, make sure I'm up to date, and let's go show in Finder. So I'm going to duplicate my sound project from last time. And I'm using this because I am going to eventually bring my sound files back in. So I'm going to call this sound version 3. And today we'll just start with a couple examples. In the next video, we'll include separate functions to finish our buttons. Let's go ahead and drag our whole folder into Sublime Text. And I'm going to open up sound version 3 and go to sketch.js. I'm going to be starting from scratch today, so I'm just going to hit Command A to select everything and delete to delete everything. And I'll make a new comment saying interaction 2 collisions. That's what we'll be working on today. The way that a collision works is that we need to determine if our mouse or some other object is inside of another object. There are more and less complex ways to do this. We're going to look at two relatively simple ways to do this using two different shapes that we've been using throughout the semester. So for our first example, we'll use a circle. And so we'll want to determine if the user's mouse is outside or inside of the circle. We can also use a rectangle and do the same thing. We want to determine, is the user's mouse inside of the rectangle area or is it somewhere out here? By doing that, we can then create different events that respond to user input. So to start, let's look at an example using circle collision. I'll add a link to this example in the notes. And this visualizes the formula that's used to tell if the mouse is inside of the circle or not. So you can see the mouse as I move it around. And at any point where I'm outside of the circle, you can see that the circle is not filled in. And as soon as I move inside the circle, my circle becomes a yellow fill. And this is done using the formula that you see down here, the distance function. So we'll create this in our own code. So I'm going to start as usual with a function setup, and I'm going to create a canvas with my usual dimensions. And then I'll create a draw function. And to start, I'm just going to draw a circle on the left side of the screen. I can use either the circle or the ellipse function. I'll use circle here. So I'll put my circle at 100 on X, 100 on Y, and I'll give the circle 100 for the size. And let's draw a background as well. So now I'm going to run my Sublime server and open up my local host. I'm now on my sound version 3 project, so I'm going to type that in. And here we can see my circle. So how do we know whether or not we are inside of the circle? We're going to use the distance function. And what the distance function does is it calculates the distance between 2 points. And because we're using a circle rather than ellipse or a shape that has some other dimensions, we know that a circle is evenly distributed all around from the origin. From the middle of the circle to any point on its edge is always the same distance. You might remember using a protractor at some point in school to draw a circle. Something that looks like this. The reason that that works when we're drawing a circle is because the distance between the middle of the circle and the drawing utensil is always the same distance. So we can create a circle. With the circle that we have here, we're just going to calculate the distance between the origin and whatever point mouse X, mouse Y is in any given frame. So let's give that a try. We'll change the fill based on whether or not the mouse is inside the circle. So I'm going to start with the fill as plumb. And what we can do is change the fill if we are inside of the circle. So first we want to calculate the distance between my mouse and the circle. So I'm going to say variable d for distance is dist. So dist is the P5 function for distance, and we can look that up in the P5 reference. Under math, if we go down to distance, we can see that it shows us the distance between these 2 points. So it's easy to calculate the distance between 2 points that are a straight line. It's harder to calculate the distance between 2 points that are at an angle from each other. And so that's why we use the distance function rather than trying to do the math on our own. But the distance function is pretty simple. You might remember it from math. If we take 2 points, so if we have 1 point here and another point here, let's call this x1, y1, x2, y2. The way the distance function works is it uses the distance between x, so that's the difference between x and the difference between y, and it uses the quadratic formula to calculate the difference in between, knowing that this is a right angle. So if you remember the quadratic formula from math, that's basically what the distance function is. If you don't remember the quadratic formula for math, don't worry about it because the distance function is going to do it for us. So we'll calculate the distance between the x, y origin of the circle, 100, 100, and the distance between mouse X and mouse Y. And then we're going to compare that distance to half of the circle. The reason that it's half is because the origin is right here, and so we only need to know the distance between the origin and half of the width of the circle, or the radius. So if d is less than 50, or half of 100, then we'll change our fill to yellow. So there you go. Now we can see when the mouse is inside the circle and when it's not. So let's create another button using a rectangle, and then we'll make our buttons do something. So here is our circle button. Next will be our rectangle button. Some of you may be thinking, why don't I use some variables? For example, I could use a variable here for x and x, here for y and y. And in the next video, when we cover functions and add to our sketch, we will use variables instead. And we'll talk about how to use variables in that example. Our rectangle button is a little bit more complicated. We have another visualization we can look at. I'll include a link to this one as well. So here's another visualization I created. You can see that when I have my mouse inside of the rectangle, the rectangle turns yellow. But if I'm on the left or the right or the top or the bottom, then that rectangle is no longer yellow. And you can see by the way that this sketch highlights that there are 4 different conditions that we need to test to make sure that the mouse is inside of the rectangle. The first condition is that the x value of the mouse has to be greater than 200, or this left line. So we know that the mouse here is larger than the left side of the rectangle. It also has to be less than the right side of the rectangle. Okay, so if the mouse X is less than 200 or greater than 400, then it won't be inside of this rectangle. Then we basically repeat those conditions on the Y. The Y position of the mouse has to be greater than 100 here, so that we know that it's below this line, keeping in mind that Y starts at 0 at the top of the canvas. Likewise, the Y value cannot be greater than 200 or wherever the bottom of our rectangle is. Doing the detection on the rectangle is actually simpler math. We're just comparing 4 values. However, there are 4 different conditions that we have to match rather than the single condition with our circle. So let's draw a rectangle and then try to fit those conditions. So I'm going to change the fill to plumb again and then draw a rectangle. So let's put our rectangle on the other side of the canvas. So I'll say the rectangle is at 400x and we'll put it at 100y, and we'll make it 100 in width and 50 for the height. The dimensions of the rectangle don't really matter. We could make it as tall or as wide as we want. We could make it, taller than it is wide. Usually a button will look kind of like this, so we'll go with this for now. We're just using some simple numbers here. Working out the math here is a bit trickier. In the next example we do in the next video, we're going to simplify it a bit by using variables. But because we're not using variables, we're going to have to do some math. So let's look at the math a little bit first. So I'm going to draw a slightly larger version of my rectangle. And so we're going to remember that the top left corner is xy. And my xy values are 400 x and 100 y. And then my width is also 100 from here to here. And my height is 50 from here to there. So the first thing I need to make sure with my mouse is that it's bigger than 400. So that one's easy. Mouse x is greater than 400. We also need to know that the mouse is less than this side of the rectangle. That one's a little tricky because we have to start with 400 and then we add 100 to it. So that ends up giving us 500. So mouse x has to be less than 500. So that way we know that the mouse is somewhere in between here and here. On the y-axis, we need to know that the mouse is greater than this top line, 100. So mouse y is greater than 100. And then it has to be less than the bottom, which is 100 plus 50. So that gives us 150. Hopefully you're starting to recognize that there's a pattern happening here. So we'll do it with the basic math, and in the next video we'll use variables. So hopefully you'll see that it's a lot easier using variables than when we do it in our head. So we're going to say if mouse x is greater than 400, and then we're going to just put all of our conditions together in one long if statement. And mouse x is less than 500. Remember, 500 is 400x plus 100 for the width. Next we say and mouse y is greater than 100, where the rectangle starts, and mouse y is less than 150, the y position of the rectangle plus the height. So now I'll do the same thing. I'll change the fill to yellow, and we should see the same effect. So we have a yellow button here and another yellow button here. So what can we do with our buttons? Let's give each one of our buttons a separate functionality. As we do that, we are going to see that we have to be careful about where we place that functionality. So let's start with our circle button. I'm going to make the circle button change the background to a random color. So to do that, I need to keep track of a color. So I'm going to say variable R, G, and B for some color variables. And I'm going to assign those to some random values. So I'll say R equals random 255, G equals random 255, and B equals random 255. And then I'm going to use RGB as the background of my sketch. Okay, so each time I load the sketch, I get a different color. And now I want to click a button to change that color. To change the color, we just have to repeat this code. So I'm going to copy that. And I'm going to place it directly inside of the if statement for my circle button. So if I'm inside this distance, then my button is being pressed. So I'm going to paste in the change color. Now we can see that if my mouse is inside of my circle, and sorry if that was a little bit alarming, that animation is changing very fast. So that's not exactly what we want. We want to be able to control that a bit more. So I could add another condition such as and mouse is pressed to my conditional statement, but I'm still going to come up with the same issue, which is that it changes very rapidly. So let's move our circle button into an event listener, which is probably more appropriate for this type of interaction. So I could put this below draw or above draw, it doesn't really matter. I'm just going to put it right here in between draw and setup. This is my function mousePressed, so this is only going to execute when I click the mouse button. And so what I can do is I can recreate the conditions inside of my mouse pressed. So click circle. To keep the visuals working, I'm going to leave most of the code in there, and I'm just going to recreate it up here. So I'm going to say variable distance equals dist between 100, the position of the circle, mouse X, mouse Y. And then if distance is less than 50, then I'm going to move my random colors up here. And I'll get rid of this mouse press. We don't need that. And so if the circle is clicked, we'll change the background color. So notice that I've just recreated the logic here because the color change needs to be in the draw loop for us to be able to see that. But we don't want to change the color constantly. So we'll leave this guy in mouse pressed, which only happens once when we click the mouse. So if I click the mouse really fast, it does keep changing, but it doesn't just automatically change for every single frame that passes as I have the mouse pressed. So that's one way to use a button. Another way is to play a sound. So let's make our rectangle play a sound. So I'm going to add a variable for my sound file. Let's use the explosion. And let's add our preload function to load that sound. And so now we have to recreate the logic for our rectangle button inside of mouse pressed. So notice again that the functionality of the button and the visual interaction of the button are actually separate properties. We don't need to be able to see the button to make it work. So for example, if I take this circle out, I can still change the background color if I'm clicking in the right place. But if I click somewhere else, nothing happens. So the reason the circle is useful visually is that it gives me a visual cue of where I can click. So even though the functionality is actually separate from the visuals, they work together to reinforce what's happening in our program for the user. So we can recreate our rectangle. So I'll say click rectangle. And so we'll say if mouse X is greater than 400 and mouse X is less than 500, so it's inside the left and right side of the rectangle, and mouse Y is greater than 100, the top, and mouse Y is less than 150, the bottom. If this looks too long, you can also feel free to move some of your conditions to the next line. In JavaScript, there's nothing wrong with adding a line in between our conditions. So now we can play a sound. So we'll say explosion sound.play. And I'll turn up my volume so you can hear that. So now I can change the background or play a sound. And of course you might wonder, can I do both? Of course I can do both. I can, put this explosion sound in here, and now I have an explosion along with the change. So I can do both, either or, whichever I prefer. So those are some simple interactions using collision detection, detecting the collision between the mouse and different shapes, the circle and the rectangle. And we can use that collision detection along with our mouse pressed event to create changes in our sketch. So that's it for this video on interaction. In the next video, we will add some new concepts using a custom function that we write ourselves to create a series of buttons to create a new version of our sound sampler. So I'm going to save this. I'm going to go to index.html and just update this to sound version 3. And let's add some instructions here in case it isn't clear, since I don't have labels on my buttons. Or I'll just say click the shapes. I don't really need to say much more about what's going to happen. Okay, so we have some simple instructions. And I think that's everything that we need here. So I'm going to go ahead and commit this on GitHub. I'm not going to add a thumbnail for this one. We'll do that with the next video, which will be the final version of our sound project. So I'm going to say adds collision interaction and commit to master. and I'll push that to the origin. So that's it for this video. As usual, let me know if you have any questions in class or on Discord, or email me outside of class. And in the next video, we'll finish our sound sampler project by adding buttons and playing sounds through mouse interaction.